All right, so guys, I'm going to be sharing with you guys some properties about logarithms, and those properties can help us get our answers to log questions a little bit quicker. I don't think we're going to need a calculator today. I don't think we'll need one today. All right. Come on back to your seat. All right. So I'm gonna give you guys some properties here. So you guys can just kind of shout out your thoughts here. But as you guys know, like if I gave you this, the answer is going to be close, but no.
Oh.
It's 3. And here's why. Because it's what power would you raise this number to get 8? And the answer is 3. 2 times 2 times 2. Right? So we're going to call these properties over here. Now, what power would you raise A to in order to get A? A to the first power equals A. This one's tricky. Yeah, that's 0. A to what power equals 1? Well, that would be 0. A to what power equals A to the x? Yeah, just x. So A to what power makes A to the power of x? Well, it must be x. This one here is a little bit weird. I don't think I'll go into the explanation as to why, but it's a lot like this one, and here's how I kind of explain these things. Remember how I said log functions and exponential functions are inverses of each other? So they undo each other. They cancel each other out. So don't write this on your paper, but this log cancels out this exponential function and just leaves you with x. You could think of it like that. Well, this is kind of the same thing. We have one big exponential function with a log in it, so these are canceling each other out. The answer is x. Okay? So I'm going to get rid of those cross-offs. I don't want those on there. But I want you guys to think of those two as like they cancel each other out. Okay? Now, I think I want you guys to know that for this, we'll write a little note here. For these two. For any log expression like this, the number that's here, the b has to be positive. The b has to be positive. If you tried it on a calculator, like if you did log and then put a negative number, the calculator would say error. It wouldn't accept that. The reason for that is because, for instance, if I gave you guys this, I said A to what power equals 0, there's no answer to that. You can't take a number and raise it to a power and ever get 0 out of it. That's impossible. And assuming the A is positive, and it always is, you couldn't ever raise A to power and get a negative out of it. So these numbers here can only ever be positives. They couldn't be 0 or negative. So both of these, if you ever see a 0 here or a negative number, those are no solution. Now, we're just going to call these our first 6 basic log properties, okay? So from now on, anytime you guys see this and this matching, the answer is 1. Anytime you have a 1 here, the answer is 0. Anytime you see these matching, but there's a power here, the power is your answer. Anytime you have this kind of a funky thing, that's going to be your answer. If you ever see a 0 or a negative, those are no solutions. So we're not going to change it into exponential form today. We're just going to know these properties and use those properties to help us get answers right away. So I like to tell this story. My wife was older than her brother, and when she got to high school, her brother was 2 years younger than her. But she wasn't like a nerd or a reject or anything like that. But her brother was pretty popular. So whenever people met her, they would say, "Oh, you're Brian's sister." Now that's kind of insulting, right? It's like I'm my own person. I'm not Brian's sister. I'm Barbara. Okay, and even to add insult to injury, she's older. Shouldn't she be the one that's more well known, right? So that was insulting her. Well, I'm telling you that story because of logs. We like to think of logarithms in exponential terms because that makes more sense to our brains, right? That's what we did yesterday. We changed them into exponential form, but logs want to be treated like their own thing too, right? And so we're not going to be changing these into exponential form today. We're just going to use these rules and get the answers directly from the logs without going exponential. Okay? So, here we go. Example 1. Evaluate each logarithm below and indicate which property, 1 through 6, you used to arrive at your conclusion. So, for number 1, I noticed that there's a 1 right here. We have a property for that, and the answer is 0. And property, what property is that? Cool. I don't have them memorized, so. All right, I notice here these are both the same. We have a property for that. The answer is 1. I think that's property, isn't that 1? Yeah. Here, I notice there's a 0 here. That's not allowed. Always got to be a positive number, so that's a no solution. I think that's property 5. Here, I notice that these are the same, but there is a power. And when that happens, the answer is the power. And I think that's property, thank you. Yep, so negatives aren't allowed, right? So we say no solution, and that's property 6. And this is the funky one. But the way I like to think of these is like this 3 cancels out the log 3, and we're left with 5x, and that's property 4. Okay. So, as you can see, we didn't do the thing where we changed it into exponential form to get these answers. We just kind of treated them like logs in and of themselves, and we're trying to get more familiar with logs as logs rather than as the opposite of an exponential function. So, here's a couple for you guys. Go ahead and take a swing. All right, so what we'll do next is we're going to use the properties still, but we're going to have to mess with stuff a little bit, okay? For every problem, the first thing we're going to have to do is we're going to have to rewrite this number before we apply the property. And I think almost every time we do it, we're going to be using property 3, just so you know. Okay, so I'll show you what I mean by that. So first of all, let's rewrite this log base 2. Now what I want to do is I want to rewrite 8 as 2 to a power. So I can replace the 8 with what? 2 to the 3rd. And once again, if you want to add that little chart out from lesson 9.8, there's a chart where I put a bunch of powers on there if you can't remember them. But now, as you guys can see, because of property 3, I'll put P3. When these match, the answer is just what the power is, so the answer is 3. So that's how we're going to be handling these. You're going to rewrite that number, and then you're going to use property 3 to get the answer. All right? So Lily, on this logarithm, what's the base? It's 5. That means I want to rewrite 25 as 5 to a power. So, Crystal, I can replace 25 with what? Good. And then using property 3, Armani, what can I say the answer would be?
2.
Yeah. All right, this next one's a little bit tricky. For number 3, say what? So when you have these matching with a log, whatever's here is the answer. Okay, so in this case it's 2. All right, for number 3, we have log, and my base is 6. Now I don't want 1/6, so I'm going to ask Amaya, how can I rewrite 1/6 so it's a 6? Put into what? No, that is, it's one of the weird ones like that. Does anybody know what we'll do, Cal? No, that's what she was saying. Does anybody remember? No, that we usually handle fractions that way, but not this time. No decimals. Yeah, so I'll show you guys. So those are all good suggestions, but what we do with fractions is we change it to a negative power. Does that kind of ring a bell a little bit now? All right. So the answer, therefore, would be what? Negative. So, that might be one to put a little star next to, because, that's a tough one for us. We would change the 1/6 into a negative one. Now, let me give you another one then, just to kind of help you guys out a little bit, since that was kind of tough for us. Log base 3. I hope this isn't already on the paper. I want to give you one that's already on the paper. Okay, all right, log base 3 of 1/9. Okay, now first of all, I'm going to change the 9 into what? 3 to the power of 2, because I need 9, right? So this is 3 to the power of 2, right? But I don't like it as a fraction, so I'm going to make it 3 to the power of negative 2. Okay? So if you don't like the fraction, just make the exponent a negative. That's it. In this case, then the answer would be negative 2. Because of property 3 once again. All right, so that's the negative exponent situation there. This one I didn't have to rewrite. It was already a 6. It was a 6 to the first power, so I didn't have to rewrite it. This one was a 9, so I had to change it into a 3 first, and then I did the negative power. So, all right, let's go ahead and take a look at number 4. This is the square root one. So you were mentioning roots earlier, and Cal, you mentioned roots also. That's where this is going to come in handy. Before we do that, though, let me ask Cal, when you have a square root, what number goes here? Because they won't write it if it's a normal square root, but there is a number that goes there. And I'll give you a hint. It's not 1. It's 2. Kind of weird, but a square root is 2. We're looking for pairs, right, with square root. And now, if there's no power out here, this is a 1, okay? So we are going to rewrite this, though. So it's going to be log base 3, and I'm going to change that. Let me ask Owen, how can I rewrite this? Perfect. So 3 to the power of 1 over 2. So this becomes your numerator, and this becomes your denominator. And then from there, we can just use property 3. So the answer is half. I'll do another square root one, because those are kind of weird. Let's call it number 5, I guess. And I guess if you want to be organized, we can call this 3a and 3b since they match. Let's do a number 5. Log, let's say 6 cube root 36. All right. So, first of all, these numbers aren't the same. So we need to fix that first. All right. So Brianna, how can I get 36 to match 6? I can rewrite it as 6 to a power. I think you're thinking of 6 times 6, which is actually 6 to the power of 2. Yeah. So 6 to the power of 2. All right. So sometimes you'll have to rewrite it so the numbers match first. But now it's a lot like the one we just did up here. So this is going to be log base 6 of DeAndre. What will I put here now? So 6, and then that's my numerator, that's my denominator, so 6 to the 2/3. And then amethyst, what would my final answer be then? Almost.
Oh.
Yeah, there you go. All right, so let's review. We've really learned 3 things here, okay? So let's simplify it and summarize it. If these numbers don't match, you're going to need to change it so it does. So like 8 becomes 2 to the 3rd, or 5 becomes 5 squared, or 36 becomes 6 squared. So you need the numbers to match. That's your first step. Get the numbers to match. Okay, that's the big one. There's 2 little things. If you have a fraction, make the power a negative. If you have a radical, change it to a fraction power. So 3 things. Make the numbers match. Fractions are negative powers. Radicals are fraction powers. Okay. So let's see how you guys handle it. Tell me what you got.